Hi, I'm Gurupkar from Loop, and in this video I'm going to be showing you how to make the best use of the Revolve feature in Autodesk Fusion 360 by quickly modeling a tank which we are planning to use in our pod design. This is the tank we plan to use in our pod from airtanksforsale.com, and here we have a picture with rough dimensions of the tank. Once you have the image, click on the Attach Canvas button on the top. Select the plane on which you want the canvas to be attached to and then select the image. Set the opacity and hit OK. Now we are going to calibrate the image to match the dimensions of the model. I'm going to select 2 points on the scale, one at 2 inches and the other at 12 inches. Enter the value for that distance, that is 254 mm for 10 inches, and hit enter. I'm going to be making this tank in 4 parts: the bottom, the neck, the knob, and the dial. Also, I will use only one sketch to model some of these parts at the same time. I'm going to start my sketch in the top plane. The first step would be to find the center of the tank by tracing its diameter. Now using the midpoint of this line, I'm going to divide the tank into two halves. This line now is going to act as my axis for the revolve function. Now I only have to sketch on one side of this line. I will trace the bottom part by using lines and splines. Make sure the end of the splines at the axis of symmetry are always perpendicular to it. Manipulate the spline handles to get the right angles. It is very important to achieve a smooth transition of surfaces after the revolve function or any other function related to symmetry for that matter. Trace the shape of the tank as closely as possible. In a similar manner, I am going to trace the neck of the bottom part. Trim the extra lines and then offset the profile for the required thickness. Over here, I am going to offset the profile by 3 mm. Finally, close the sketch and the profile for your first part is now ready. In a very similar way, I am now going to complete the profile for the neck. Note that I am continuing to draw in the same sketch. This completes the neck. For the knob, I'm gonna use some more tools like the fillet tool to have smooth edges and the mirror tool to fasten the sketch and to maintain symmetry. Mirror is one of the tools I use very often. If you learn to use it right, it can save you a great deal of time and effort. That's one tool you definitely want to master. This completes our knob. Now we are going to revolve the sketch into 3 different parts. To use the revolve tool, simply select the profile, the axis, and the angle. You now have a solid part. In a very similar way, now I'm going to revolve the neck and the knob profiles. As you can see, this has come out as a single part. That is because while revolving, the operation was set to join. If I go ahead and edit the revolve from the history line and change the operation to new body, I now have 3 separate bodies. To make the remaining parts of the neck, I'm going to repeat the exact same method I used up till now. The only difference is that the axis for these parts is going to be horizontal as opposed to vertical. As you can see, I first trace the diameter, then divide the parts into 2 halves by sketching a line through the center of the diameter. This line will act as the axis of rotation for these parts. Again, I will be revolving 3 different parts using the same sketch. This trick can save you a lot of hassle when you're modeling complex parts. This way you will also not have to deal with a large number of sketches as your overall number of sketches will remain very less. As you can see, when I try to revolve these parts, they turn red, and the operation by default is set to cut. This will cut the revolved part from the selected parts. This happens when the part being revolved is overlapping an existing part. I'll just change the operation to new body because in our case I'm just going to combine these parts in the end, so it doesn't matter if they overlap for now. Now I'm going to start making the dial assembly. I will simply extrude the neck of the dial assembly and do another revolve for the dial later on. This completes the neck. To make the dial, I'm again going to use the three revolved parts from a single sketch. These parts will be the outer cover of the dial, and the glass covering of the dial. As you can see, I'm using the exact same method as I've used twice before in this video to efficiently create multiple revolved parts. I'm once again using fillets for smoother edges. This will help me to get a more neat and realistic rendering of the model in the end. Now as you can see, I did not pay attention while I was selecting the plane for my sketches, and this resulted in the dial being far away from its intended position. This problem can be quickly remedied by using the Move tool. I have found the Move and the Assemble tools of Fusion to be very efficient and fast as compared to other CAD softwares. Now our dial is in its correct position. Time to get rid of the excess solid material. To do this, I will again use the same sketches to revolve cut the excess material from the neck. As you can see, the red highlighted volume will cut the excess material out of the neck. I will then repeat this two more times to get rid of all the excess or overlapping material created earlier when I revolved these parts in the earlier stages. After getting rid of all the unwanted excess material, I will now combine the three parts of the neck into one single part. This can be easily achieved by using the Join tool or the Combine Parts tool. After applying some fillets to round off sharp edges, our model is now ready to be mirrored. As you can see, the mirrored portion has an open hole in the neck. To close this hole, I will again use one of the existing sketches and select the From Object option to create an extruded shape from an offset surface. Finally, I will give it a nice fillet to blend it in the neck. And now our final model is ready. I can now use this model to see where, how, and if it will fit in the pod design. This is a very quick and efficient way to start a design process. I hope you like this video. Stay tuned for more from AZ Loop.
Yeah.